True. Always true. True. Always true.
Good afternoon, ladies and gentlemen. Today, we are going back to functions. Now, I'm not gonna lie, I don't, so I remember the last time that we did this, I had some criticisms for the course, but I do want to stress that I still think it's a good course. I still haven't been enjoying my time, with it and my time, like, learning from Mr. Gakwaya, and it's been a good time. Today we're going to continue our lesson on functions. The lesson, let me look at it real quick. So we're at the 15-hour and 50-second mark. This puts us a little bit less than halfway through chapter 11 on function, which is on functions. And it should last an hour, according to when the next chapter starts. The next chapter starts at 16:03, 16 hours and 3 minutes. So we're looking at, probably for the stream, probably in the neighborhood of 2 to 3 hours. I don't know exactly how that's going to look because it depends on it kind of depends on how much stuff there is for us to do practically and how much of it is going to be well, like last time where I was doing a lot of sitting around and listening to the lecture. So we're gonna try and keep things interesting. It's gonna be a lot of so the sections of this chapter that we have are function declaration and function definitions, which I feel like I can kind of intuit, but I'm not 100% since we haven't actually seen the lesson yet. And then there's multiple files, compilation model revisited. I don't know exactly what this is going to be covering, except maybe something similar to what we did in the one definition rule section, where where he demonstrated that we can have multiple CPP files and a like a C file, and call on it in like as like include it as like a header essentially. I don't know exactly how what the terminology is, but we included a file when we were checking out the ODR. And then it's a bunch of pass by things. So we'll see how it all goes. It'll be it's sure to be interesting. I hope it's as interesting for you guys as it is for me. This has been a very good time so far. So let's get our show on the road, shall we? What? So there's one, and then this one. It's always different. All right, there we go. All right, let's get this going. Take it away, Daniel Gakwaya.
In this lecture, we're going to learn about function declarations and
Oh God, that's
function
loud.
definitions. The motivation for the topic
Okay, there
we're
we
going
go.
to be talking about here is that sometimes you really want to separate a function header from its implementation because you don't want to expose all the details about how you do stuff. Let's look at a simple example. In the last lecture, we declared a max function which was computing the maximum between two numbers. The output was an integer, so that's what we returned. The name of the function was max, and we had two parameters, int a and int b. But what we did in the last lecture was crump the entire function body in front of main, but sometimes people don't want to really see the details of how you do stuff. They just want to know a summary of what your function does, what we can get out of the function, and what we need to give to the function for it to do its job. And that's what we're going to see in this lecture. If you look here, we have the function header in front of the main function. And the function header is made up of its return type, the name of the function, and the list of the parameters. And after that, we're going to put a semicolon. This is called a function header or a prototype. And when we do that, the compiler is going to be happy and it's going to work with us to compile our program. But when we get to link our program to really put it together and make one binary, the definition of the function is going to be needed. And if you look after main here, what we have is our function definition. If you look closely, you see that it is exactly the same thing we had in the last lecture. We have our header information. We don't have a semicolon after our parameter list, but we have a pair of curly braces. And inside these curly braces, we have the body of our function. Now, it is really easy to look at this program because we don't have to look at all these details about how this function works. We can get first-hand information on how we can use this function, and that is what most people are going to be interested in about your function. They won't really want to go in and see how you do stuff. They will want to use your function to get the output and use it to do whatever it is they want to do. If you look here in the body of the main function, we have two variables, a and b, and we use them to call the maximum function. We can also set up a minimum function which works in the similar way, and we call another function called incremult, which is going to increment and multiply whatever arguments we pass to this function. So the main idea here is that we can split our function in two parts. One is going to be the function header, which is really going to be the function declaration, and the other is going to be the function body with all the details about how the function works. And that's going to be our function definition. And one
Okay, so this kind of makes sense because we covered this a little bit last time. I think it was during the one definition rule when I was super confused about everything. And one of the things that I was confused about that I actually got an answer for was this declaration definition thing, because I was kind of under the impression that the definition also needed to be above the main, I guess, body, whatever you call it, the main part of the code, which isn't necessarily true, obviously. We do need to we do need to declare it, and then before this can before after we've declared it, if we want to use it for anything, it needs to be defined. It needs to have something that it can do. But we don't actually. It doesn't necessarily need to all be at the top. That said, I'm not sure why you would declare something and then not define it right there. I feel like I feel like that's a bit. I mean, maybe unnecessary. Like maybe I could maybe see an argument for like declaring it two different ways, or declaring it. Well, no, because that violates the one definition rule. If you declare it and then want to define it a different way somewhere else, you'd have to create a new function, and then you'd have to declare that one anyway. So I don't know why you would do it this way. It just seems like there's potential for misunderstanding here if you declare it and then don't put the definition right next to it, at least.
Once we have these two things in place, we can call the function in our main function and do whatever we want with it. Okay, now it should be super clear that we can separate our function in two parts, declaration and definition. And sometimes the declaration part is also called a prototype. That's a prototype of a function, and it is made up of the return type together with the function name, together with the parameters, and after that you're going to add a semicolon to make it valid C++ syntax. And another thing you should know is that the prototype needs to come before wherever it is called. If you're trying to call a function before its prototype is seen in your C++ program, you're going to get a compiler error. And now you might be asking, but why did our programs in the last lecture work? We didn't split things up and our program was working fine. Well, if you put a function definition in front of the main function, that function definition is also going to double as a function declaration. That's why the code in the last lecture worked. Okay, now that you have an idea about what a function declaration
but I still think that you should define it right after. It feels a bit weird not to.
Okay, here we are in our working folder. The current project is function declarations and definitions. We are going to grab our template files like we always do. We're going to put them in place. And we are going to open this guy in Visual Studio Code. Let's do that. We open this up. And we are going to open our main CPP file, clean it up a little bit. And let's close this pane so that we have some breathing space. The first thing we're going to do is set up a maximum function. You already know how to do that. We're going to specify the return type. We are going to specify the function name and the parameters. We're going to take in int a and int b. And we're going to go in and do whatever we need to compute the maximum between these two guys. We're going to say if a is greater than b, then a must be the maximum. So we're going to return that. Else, we are going to return b. Okay, this is the function, and it is really simple. We can go down in main and use it. So let's say int x and put in a 5, for example, and let's say y and put in a 2 or a 3. Put in whatever you want. And then we're going to set up the result variable, which is going to catch the maximum. I think we can do that. And what we're going to assign to this is whatever is returned from our function call. So we're going to call this function with x and y. So we're going to be computing the maximum between 5 and 2 here. The maximum is going to be stored in this result variable, and we're going to print it out. So we're going to say std cout, and we're going to say max as result. This is going to do. Okay, let's try and build this and make sure it actually works. This is nothing new so far. It is everything we have done in the last lecture. Now the build is good. We can clear and run rooster, we're going to get the maximum as a 5 here. And if we try to change this,
Yeah, so again, this is what I was talking about, is like technically speaking, we could omit this part for now and like put it somewhere else. But this feels this seems like it's the way that I would want to do it. I don't know why you would change it later. Why you wouldn't just define it as you declare it. It just seems like it seems like it creates too much potential for mistakes or or forgetting to do certain things.
things, for example, make y a 12 and build again. We're going to use GCC, and we are going to clear these things and run rooster. We should get max equals 12. This is all fine and dandy, but sometimes we don't really want to have the details about how our function works shown in front of the main function here. And we can
But
split
why?
our function in two parts, a declaration and a definition. The declaration is really going to be the header part of the function, and that's going to be the return value, the name of the function, and the parameter list. But to make it a valid declaration, we have to put a semicolon after this. So this is our function declaration. Sometimes it is also called a prototype. And please make sure you understand the difference between a prototype and a signature. In the last lecture, we saw that a signature was only made of the name of the function and the parameter list, but the return value was not part of the function signature. But the prototype includes all these guys. So signature doesn't include return type. Okay, so now we have our function declaration set up. We need to put in a function definition, because if you try to compile this program and link it, you are
It's not
going
to work
get,
because
well,
this doesn't mean
let's try and
anything.
do that before we put in the definition. We can build with GCC. We are learning, so we don't have to fear breaking things a little bit. Let's clear and try to build with GCC. And you're going to see, we have a problem here. And what kind of problem we have? The C++ compiler is going to compile this program, but when we
Hi,
hit
I am
the
awake.
late
No college
stage,
tomorrow.
I
Nice.
realize I haven't really talked about this in more detail, but we will do in this lecture. But the main problem here is that we don't have the definition of this function in place, and the compiler is going to search for it and not find it.
Right.
And you see that it is saying undefined reference to max. Okay, so it has seen the declaration of the function, but it doesn't know how the function does its job because we don't have a function body in here.
Yeah, we
So
didn't
to
define
really
it.
make this code work exactly as we want, we need to put in a definition. And the definition can show up anywhere in your C++ program. In this case, we're going to put that after the main function, and the definition is really what we have been using so far as our function definition in the last lecture, but notice that it has the body information, and now when the compiler tries to compile this program, it will know how the maximum.
I was waiting
function
yesterday
is
for the stream, but I
computing
didn't
its
stream.
maximum,
Yeah,
because we have all
I
that
didn't stream
information.
yesterday.
So
I
let's say
woke up
that this
like
is our
way
function
too late,
definition, and shows up
and it
after
was
main
not.
in this case. And we can
I was
try
not.
and build
I was
this
not feeling
and
up
see
to it.
if the
I put
build
a
is
community
good. Now you
post
see the
out.
build is good. And if we try to run it, we're going to get our maximum exactly like we did when we had the declaration and the definition cramped up before main here. But hopefully now you can see that our program is much cleaner, because when you look at this, you know that we have a function called max. It's going to take two parameters. It's going to return something, and it is called max, so it must be computing the maximum of these two guys, but we don't really care how this function does its job, how it computes the maximum here. And this is the main message here. We can split our function in two parts, a declaration and a definition. Okay, just to play around, we can also set up a minimum function. Before we do that, let's set up its definition down here. We're just going to copy the maximum and adapt it. We're going to put a copy of that guy here. We're going to call it min. It's going to take two parameters. It's going to return an int. But what we test for is if A is less than B. If A is less than B, then A is our minimum. If A is not less than B, then B must be our minimum. And we can put the declaration of this function on top here. So let's go there and say men and say int A and int B. And now we can change the call here to say min, and it is going to compute the minimum. Why not? Let's do that. We're going to say min here, and we're going to grab whatever is the minimum between x and y here, and that's what we're going to have in this result variable here. Let's do that. We're going to try and use this. The bold is good. So we're going to clear and run rooster. Now the minimum is 5. We are calling our minimum
I didn't change
function.
the text here, but it is calling
In the last
minimum.
lecture, we also set up a function to...
But it is pulling the minimum when I do this. Include bits std c++.h. Why? If you include this, there is included max function pre-made, and most of the useful libraries are in this giant library. There is a max function by default in the math-h library. Yeah, well that's helpful. I'm mostly or not mostly. I'm thinking about why I still don't understand why we would want to do this. Why we'd want to do these definitions after the declaration. It feels to me like I mean, if I create stuff up here, it seems like I'd want to define it before we use it. I mean, I guess if we do it at the end, it's kind of like a glossary. That's kind of the thing that I don't get. It seems I still don't like. I get that this works. I'm just curious as to why we would choose to do something in this way.
To increment and multiply, let's try and do the same thing, but split that into a declaration and a definition just to practice a little more. We're going to call this increment, and it's going to take A and B in, and inside, and we're not going to put the body on top here. We're going to put the body down with the other definitions that we have for all these other functions for max and min here.
Okay, hold on. What was this one called? It was incmult. It takes 2, so integer increment multiply or whatever the hell. Int A, int B. Let me do it like this because the compiler G++ sees that first. So is it like an efficiency thing? Or like uses less memory or something like that? Or runs faster or something? Alright, let's create.
And we're not going to put the body on top here. We're going to put the body down with the other definitions that we have for all these other functions for max and min here.
I mean, if it's more efficient than that, I guess that makes sense.
So we're going to put a body inside these curly braces, and we are going to return plus A. We're going to increment A, and we're going to multiply that with an increment of B, and we're going to return that. I think this is going to be valid C++ syntax. And if we try to call this function in main, let's do that, say increment, and we're going to pass in x and y. The program is going to just work fine. We're going to grab the result and store that in our variable. Let's do that. And we can print the...
After you do this tutorial, what are you planning to do? The plan after I eventually finish this is to go to probably Unreal 5 stuff, because I have a little bit of experience with Unreal 5, but I didn't decide. I fell out of practicing with it like I wanted to, and ended up stopping altogether, which is something I'd like to get back to doing that, because it's kind of, yeah, it's like long-term dream, I guess, you know. Game dev noise, yeah, that is the hope. That is the hope. We'll see it eventually, hopefully.
a
Alright, well,
result. We're going to do that with an increment of b,
alright, so this looks correct.
and we're going to return that. I think this is going to be valid C++ syntax. And if we try to call this function in main, let's do that, say increment, and we're going to pass in x and y. The program is going to just work fine. We're going to grab the result and store that in our variable. Let's do that. And we can print the result. And we're going to say result here. This is going to do. And if we build and run this program, we're going to see the output here. Let's see what we get. The result is going to be 78 because if we increment a 5, it becomes a 6. If we increment y, we're going to get 13. 13 times 6 should be 78. Let's be sure. We're going to bring up a calculator.
Is that how we're doing this? Hold on, let me see. Before I run this, is that how this will work? So we have our x and y, so then we do increment, so 6 times, I think that this would be 6 times 13, right? Is that what he said? 6 times 13, does that make 78? 6. Because this does just... Because it increments them first. And it's 6 times 13. Try seeing some open source stuff in it. And why not participate in Google Summer of Code? If you don't know this, Google it. I don't know that. Many game engine organizations go there, so it's a very good way to practice and to see how real code works. Really? Hold on, let me write that down. I'm gonna open up a notepad real quick. Stuff to Google Summer of Code. Game engine organizations, huh? That's me, not you. Let's see. Because I've seen I've seen memes of like game dev stuff for years with like people like Yandev, you know, Yandev, and it's like people clowning on him for his giant walls of if thens. And I think Toby Fox also to some extent. LOL, I'm on Linux. Different noise then. The only Linux I've ever messed with really was like I think Ubuntu, but that was a long time ago. I think that was on my first laptop. And it didn't really help me any because I wanted it for gaming and it was just an old work laptop from my dad, so it wasn't particularly good for gaming. Served me for years though. Let me see.
6 should be 78. Let's be sure. We're going to bring up a calculator. Let's do that so that you know that
6.
I am not making these things up. 78. So
Yep.
our program is really working like it should. And this is the main message here. We can really split our functions into a declaration
Oh,
and a
wait, I fucked something. What did I fuck? Incmult. Error, redefinition. Where is it? 41? Ooh, I fucked it. Linux is not viable for gaming. Steam Deck made it good though. I mean, from what I understand, is it's one of those things where it can be viable, but you have to jump through so many extra hoops in order to make it viable, and it's kind of a pain. Like you can not every game has support for Linux and all that stuff, and it seems very no return statement in function running non-void. Oh, wait. Anti-cheat shit just straight up won't work. Oh no. Alt. Okay, so why is this considered a redefinition? Oh, is it? It's because I put those, isn't it? Let's try now. Yep, it's all because I putting those little brackets, man, or those curly braces, I should say. Very all right, let's see. Roo star. Yep. All right, minimum is 5 and our result is 78. There we go. My god. It's like, "Oh, what did I mess up?" It turns out that's a very important thing to not do if you're just creating a declaration.
Definition, and that's going to make our programs much easier to work
Semicolon
with
error.
and read. One thing you should know is that the names of the variables aren't really important in function declarations like this. So for example, we can take out the A and B here, or we can take out all the variable names in our function declarations. Let's do that.
I also had this
And you
one
might
learning
think,
JavaScript.
is this program going to compile? Well, I hate to break it to you, but it is going to compile. So let's build with GCC.
Semicolons are shit in general. They're
good.
very frustrating to deal with. So we don't need variable names in here, which is really weird to me because it feels like the kind of thing that I mean, I guess it does. I guess it kind of makes sense because like all you're really telling it is that it needs to take in integers, right? Like all you're saying is, hey, you take this type of data and you perform whatever function with it, and it doesn't really matter what you've called it. I guess if you need to reuse it somehow, like when we did last one the day before yesterday, uh, we called it A and B, and then we had we did some other thing inside of the function using A and B, and that was in that situation I can see it being important to do that. But with something as like fairly simple like min and max, it seems like it kind of makes sense that you don't necessarily need it. Or is it only in the Oh, no. Okay. Now I see no, I'm seeing what I thought I understood and did not actually understand. What I thought is that it's I think it's because it's only a declaration and it doesn't actually have our definition. Like this we definitely need it. It's just in the in this section where we're just declaring it. We don't need to name everything. Right? What are you doing, kitty? Meow. Yeah, that still works. Okay.
Function header or a declaration doesn't really care about the variable names. In the definitions, we care about these variable
he's
names
literally. Oh my
because
god,
we
he's
are
going
to
into
be
it as
using
soon as
them in the
I.
bodies. But if you want, you can leave them out in your function declarations. But I like to keep them in place because I like my functions to be self-documenting. If somebody looks at this, they will know the variable name here. But if you really want, you can leave the variable names out, and it is going to work pretty well.
I mean, he talks about it being self-documenting, but I feel like it kind of makes more sense to me than to put the definitions with the rest. But I mean, if it's more efficient the other way, I guess not. I guess it's better to just that's gonna like frustrate me that this is a better way to do it than than what is intuitive to me.
This is really all we set out to do in this lecture. I hope you found it interesting.
Okay.
We are going to stop here in this lecture. In the next one, we're going to see how we can split our programs in multiple files now that we know how to split into declaration and definition.
Okay.
Go ahead and finish up here and meet me there.
Okay. So give me a second. I need to go to the bathroom. I will be back in soonish, hopefully. Yeah, I gotta go. I'll be right back. 1 sec. Sorry about that. I had to go. All right, let's continue this, shall we? All right, functions across multiple files, compilation model revisited.
In this lecture, we're going to revisit our C++ program compilation model. Along the way, we are also going to see how we can work with functions across multiple files. If you remember, our compilation model looked something like this. You have seen this slide a lot of times by now. What it describes is what happens when we compile our program. The moment we run the compilation command, our C++ program, which lives in the main CPP file by now, is going to be passed through the compiler. The compiler is going to process it, and it is going to come up with a binary executable that is mostly called rooster in this course. And when we execute this rooster file or binary file, we're going to get the program to run. The program is going to be executed instruction by instruction when it is loaded by the operating system. And we are mostly going to see the output of that program on the terminal in this course. This is the compilation model we know. But now what we want to do is zoom in on this compilation part here and see what really happens under the hood. We are going to suppose that we have our program, which is made of a lot of source files, as we have here on the left. Suppose we have 2, 3, or 5 source files, unlike what we have so far, which is one file, the main CPP file. When you compile such a program, you're going to go through a stage called pre-processing. And what this is going to do, it's going to look for your include statements, and it is going to take whatever file you are including, and it is going to paste that in place. So for example, here you see we have an include IO stream statement. When the pre-processing stage is run, this include statement is going to be replaced with whatever we have in this IO stream file here. So this is going to be wiped out, and we're going to put in the content that we have in IO stream in this exact place where we have the include statement. I hope this is clear. So when we go through pre-processing, we're going to have a version of our source files with the included parts put in our source files. We're basically going to go copy everything in that file that we include, and we're going to paste inside our new files here that we're going to be referring to as translation units by now. These are translation units in a C++ program. Once you have these translation units, then you're going to compile them. They are going to go through the compiler. The compiler is going to generate what we call an object file, and this is a binary representation of the content you have in your translation unit. So each translation unit is going to generate one object file. And for example, if you had 20 translation units in your program, you're going to have 20 object files. Once we have object files, they are going to be processed by what we call the linker, and the linker is going to stitch them together and have one single binary file out of all these object files. So we're going to have something like this, and this is basically going to be our binary that we can run on our target operating system. So by now you see that our compilation model has expanded to contain 3 phases. We have pre-processing, compilation, and linking. Now you might be asking, why am I showing you this now? Well, it is going to matter because we're going to split our program across multiple files. Some of those files are going to matter on the compilation phase, and some of those files are going to matter on the linking stage. So we really need to make a clear distinction between compilation and linking here. Okay, this should be a more complete compilation model to go by for now. Now that we know about this compilation model, we can look at how we can split our program across multiple files. Suppose we have 3 functions. One we can use to get the maximum of 2 numbers called max, a function called min we can use to get the minimum between 2 numbers, and a function we can use to increment and multiply like we have seen in the last lecture. Now the 2 functions max and min are going to live in their own file, and that file is going to be split in 2 files. We're going to have a header file and a CPP file, which is going to contain the implementation. In the header, what we're going to have is just a prototype. And we are going to set up our code in a way that our anchor mult function here is going to live in its own file. We're going to split that in two files. So we're going to have a header file called operations.h, and we're going to have an implementation file called operations.cpp, which is going to contain the implementation of this function here. When we hit the main file, what we're going to do is nothing special. We're just going to include the headers, and we are going to use these functions like we have been using them all along. If you look on the first line here, we are calling max. On the second line, we are calling men. And on the third line here, we are calling anchor mult to do whatever it does. Okay, when you start splitting your functions between the definitions and the declarations, remember the one definition rule.
Right. We covered
that
this
you
in the
can't
very beginning
have
of
a
this
function
chapter.
defined multiple times in your entire C++ application. If you do that, the linker stage is going to find those two functions, and it's going to not know which one you really want to use, and you're going to get a linker error. We're going to see that when we hit Visual Studio Code in a minute. Another thing is that you know that your definition can really live anywhere in your code. The linker is smart enough to parse your entire project looking for the definition for whatever function it found in your source code, and it's going to keep looking until it finishes looking in all translation units, and when it doesn't find the definition, it's going to give you a linker error, which is probably going to say undefined reference to something, and we're going to see an example of this in a minute. Okay, now that you know about this updated compilation model and you have an idea that we can split our functions across multiple files, we're going to head over to Visual Studio Code and play with us.
All right, let's play with
this.
this.
Here we are in our working folder. The current project is multiple files here. We're going to grab our template files. Let's copy that and put that in the project of interest. And we're going to open this in Visual Studio Code. Let's do that. We're going to open the folder. We're going to choose the project and open it. And we are going to open up the main CPP file here and clean it up a little bit. We are going to set up a max function. And remember, the function has to show up before it is used somewhere. And we are going to split this into a definition and a declaration. I think we already know how to do that. So let's do that. We're going to put a definition down here, and we're going to change what we have on top here into a declaration. Let's say that to be super clear. And what we have down here is a definition. And we can call this function. We're going to set up a variable which is going to store our max, for example. And we're going to assign whatever we get from the function to max here. So we want to find the maximum between 34 and 56, for example. And we're going to print this out. We're going to say max is the maximum. And if we build and run this program...
hold on. We're gonna get my shit. I'm a little bit slow. You gotta see. Alright. Do like this. This is why I like following these videos, man. It gives me the ability to just like be like, stop! Wait a minute! Max. Oh, whoops. Int max equals max 34, 56. And then we spit out our max value here. Expression preceding parentheses of a parent call must have pointer to function type. What? Alright, well he's got the thing too, so hopefully
to say max is the maximum. And if we build and run this program, let's use GCC to do that. We have a compiler error here. What is that? We need a semicolon, not a colon here. I think the squiggly line is now going to go away, and our things are named the same way. The compiler is not going to like it. Let's bring up a terminal so that we see our problems tab. Expression preceding parentheses or paracle must have. Okay, the problem here is that these two guys, max and max, are called the same, and this is going to confuse the compiler a little bit. So what we're going to do is call this maximum.
Yeah, because these had the same... So these had the same name, but being different things, they had different definitions. So...
No big deal here. And we're going to do maximum here. And the compiler is going to be happy. Now we can compile and build this program. Build is good. And if we run it, we should get our maximum printed out. Let's see that the maximum is 56. And if we change 34 here to be 134 and build again, we should grab that as the maximum. Let's see if that's the case here. Run the program. The maximum is 134. So this is working exactly as we want. The next thing we want to do is to split this function across multiple files. So we're going to set up two different files. One is going to be a header file. The other is going to be a CPP file. And you have to follow this structure in C++. So we're going to go on the left here and add a new file. In Visual Studio Code, you can click on this little icon that says new file to create a new file. Once you do that, you're going to be given this little window in which we can type the name of the file. We're going to call this compare.h. It's going to be our header file. And we're going to add another one, which is going to say compare.cpp. Okay, our two files are going to be compare.h and compare.cpp. And they are going to contain our functions to compare stuff. So we're going to have a function called max and another function called min for computing the minimum. Let's go there and actually do that. We're going to move our declaration in the header file. So your declarations are going to be living in header files. And we're going to grab our definition and move that in another file called compare.cpp. So I'm just going to cut it out and paste that in compare.cpp here. Once we do that, we're going to go back in main and see that we have a problem now. The main function doesn't know what this max function is because it's not declared anymore. And if we're trying to compile our program, we're basically going to get the same error we see here in Visual Studio Code. Identifier max is undefined because it doesn't know what this function is. So we need to do include. If we ignore this and try to build, let's do that. We are learning, so no big deal here. We're going to get an even much weirder error, but the message is going to be the same. Max was not declared in the scope, so the compiler doesn't know what to do with whatever we type here. But there is a way in C++ we can...
That is actually so clever. I can't believe I didn't even consider that. Where we have one file that is just for our headers, essentially, and it has a bunch of declarations. And then we have our CPP file has our... like a CPP file with all of our definitions in it. And then this where we just use it all. Holy shit.
Can solve this problem by including the header that contains our declaration for the function that we are using here. We can go back in main and do that, and we're going to say include, and we're going to say compare.h. That's going to bring in our header. And if you wait a minute, you're going to see that the squiggly line is going to go away. So what happened, the preprocessor is going to come in and copy whatever we have inside compare.h. It's basically going to go in compare.h, copy everything we have in here, and come back in main and paste all that in the place where we have the include directive here. This is called an include directive, or an include preprocessor directive. This is what the preprocessor is going to do here. And now if we try to build this program, let's try to do that. We should be fine. Build, finished successfully. And we can run our program to see the maximum printed out. Let's run rooster. Maximum is 134. Now everything is working. Let's add another function here because just having one function is really boring. So we're going to put in a main function. It's going to take int a and int b. And we're going to go in the CPP file and put in another definition for the minimum function here. We're going to call this
I
man.
thought you were peeing for 20 minutes.
Let's
I was watching
do that.
Instagram and split screen. I didn't see that the stream was paused. Oh, yeah,
Let's
no,
call
no
this
worries.
man. And we're going to
I had
test
to go.
for
I
A
had
is less
to.
than B. This is going to give us a
I
minimum.
had to do a
And
little bit
now
more
if
than
we
that.
go back in main CPP, we will be able to use our minimum function because it is brought in also by this preprocessor directive we have here. So we can go down and say int minimum, and we're going to say man, and let's grab 146 and 23, why not? And we're going to print the minimum here, and we're going to build this with GCC.
Then here.
The build is going to be good. If we run this, we should see both the maximum and the minimum from these calls we make here. Okay, by now we should have an idea about...
Okay, so here, I mean, it doesn't really matter what the numbers are. I don't think. That's not nearly as important as making sure that all of this stuff is working. Calling this one minimum. Minimum. Make sure this is correct. Yes, okay. So this is where we create the minimum. And then now this should work just as well. Terminal run task, G++. This is... here we have our minimum. Oh, whoops, I ran the wrong function there. Min. Terminal run task. Let's try again. Should be 15 for that one now. Nice. Okay. Okay. That's actually so cool how this fucking... Okay, this I can fucks with this. I can appreciate these the way that this is done. Where we have declarations in one and definitions in the other. It's like here's your dictionary and here's your glossary or I mean I guess they're both kind of a glossary, but like this one is like, okay, we're gonna just show everything that we use, and then here's how it's all used. Here's what the function does. That's actually so cool. I can't believe that I didn't even consider that was a possibility.
How to split
Like
your functions
this hadn't been
across
explained, but I guess
multiple files.
it makes
You should
perfect
also know
sense.
that you will have to include whatever header contains the declarations for the functions that you want to use. Another thing I want you to see is that the definitions for your functions
I might be
don't
wrong, but this
have
is
to
some
live in
nanosecond
a
slower.
file that is named the same as the
I mean, still.
header file. For example, here our header file is called compare, and the compare CPP contains our definitions. But the definitions don't have to live here. They can really live in any translation unit that you have in your C++ program. In our C++ programs, the translation unit is mostly equivalent to a CPP file. So let's set up another file and show you that we can move this definition there and the program is going to keep working. We're going to add another CPP file and call it some other file. .cpp. It has to be a CPP file because it's going to contain the implementations. And let's take the implementations, for example. Let's take them all and put them in another file. Why not? We're going to grab all these guys here. Let's cut them out and put them in some other file. And we're going to build this and see that it works. It should, because the linker is smart enough to go find these definitions and whatever translation unit that we have set up in our project here. And you see the build is good. We can build this, we can run this, I should say, and we're going to have our output here. We can even take one of these guys, let it live in our compare.cpp file. For example, let's take the minimum function here, and we're going to bring that back, and we're going to build. Notice that now our maximum function is living in some other file, and the minimum function definition is living in compare.cpp. But if we build, this is going to work. Again, the linker is
doesn't care.
going to parse all
Linker
the
don't give a shit.
units
That's
looking
awesome.
for whatever definition it needs to find. And in this case, it will be looking for the maximum here, and it's going to find that in some other file. And for the minimum function here, it's going to be looking and compare, and it is going to find it. And the build is going to be good, and we can run the program again and see our output here. One thing I really need to point out is that if the definition is not available, let's say the minimum function here is not there, we can comment it out to hide it to the compiler or hide it from the compiler. And if we try to build now, we will get a linker error. Let's try to build with GCC. Build finished with errors. The terminal process terminated with exit code -1. But the main message here is that we have an undefined reference to min int end. So when we compile, the compiler is going to be happy with the declarations that it has found in our compare.h file.
I was recently working with HTML5 and can't do this thing. Annoying. Oh no.
If we go there, we see that we have a declaration for max and a declaration for min. The compiler is going to be happy. It's going to compile our code. And when the
Hello,
compiler
ABC, you know
compiles,
me.
it's going to generate object files, and it will hand the job over to the linker to stitch all those little object files together to have one single binary file. When the linker tries to do that, it's going to look at main because that's where it's mostly going to start from. And it's going to see, main is calling minimum here. Where is the definition for the minimum function? It's going to parse every single translation unit in the project. It's going to come here in compare.cpp, it's not going to find it. It's going to look in main.cpp, it's not going to find it. It's going to look in some other file, it's not going to find the definition. And the linker is going to say, I didn't find my definition for the minimum function, so I'm going to throw a linker error, and you, the developer, you're going to fix this problem. And
you must fix this problem.
And again, this is
it is
a
your
linker
fault.
error. GCC doesn't give you more visible stuff to show you that this is a linker error, but what you should look for is LD returned 1 here, because LD is the linker that GCC uses. So this is a linker error. I think I should show you how a linker error looks if you are using a Microsoft compiler. So we're going to build again, but now we're going to build with MSVC. If you don't have Visual Studio, that's not a problem. You can keep using GCC, but I just want you to see how different compilers handle these errors. I have the luxury to do that because I am developing this course on a Windows machine, and I have a Microsoft compiler handy that we can use directly from Visual Studio Code here. So I am going to choose this compiler, and you're going to see that it is going to start building. It is building, and it is going to fail and throw a linker error also. So you see here some other object file. Okay, when this object file was being taken and stitched together with other object files to put together our binary, it didn't find the definition for the minimum function, and it is going to throw a linker error. And in Visual Studio, you're going to have a problem like this, LNK, and it's going to give whatever version of the compiler you are using, but...
Wait a second. I'm not seeing that. So the GCC one worked fine. I could understand. I mean, it's not like a huge deal. I don't think we've used MSVC much at all during this. I think we used it like twice during the course. Not particularly common thing. Not recognized as an internal or external command. Offerable program or batch file. Okay, so I must have just fucked that one up, I guess. I don't know. It's probably just not working properly. I think I fucked up initializing the what is it called? The fucking compiler. Yeah, I think this just doesn't. This one's just not working. Whatever. We have GCC. GCC works.
Down here you see unresolved external symbol. This is how Visual Studio says it. And it's basically going to be an undefined reference to something. This is just Visual Studio's compiler's way to say this. And again, it's going to say this is a linker error here. It is basically the same error we saw when we were using GCC in a minute. Visual Studio, the compiler from Microsoft, is also going to put a lot of junk in our folder here. So let's remove all these things. I'm going to select them all and hit delete here. And they are going to go to my recycle bin. And we have another one here we should remove. Let's remove it. And now we should go back in some other file, .cpp or compare.cpp. That's where we have our minimum function. We can activate it. And if we build now, the build should be good because the linker is going to find this definition here. Okay, let's build with GCC because that's my favorite compiler. Now you see that the build is good. We can clear and run Rooster, and our program is going to work as it should. This is really how you can split your functions across multiple files. The headers are going to contain the declarations. The CPP files are going to contain the definitions. Your definitions can really live anywhere. It's going to be a matter of what works better for your project. But for organization purposes, your CPP files are going to be basically like this. You're going to have some declarations in the header like compare.h. And in a corresponding CPP file, you're going to have the definitions for whatever declarations you have in the header. But you don't have to do it this way. If it makes sense for your definition to show up somewhere else, please go ahead and do that. C++ is going to accept that. This is really all we set out to do in this lecture. But before we go, I'm going to give you a chance to set up another function. Suppose we have a function called anchor mult, and we're going to have the function set up in here. We're going to return a++. We already know how to do these things. We've used this example a couple of times by now. ++b, and that's what we're going to return. Now your job is to split this function into a declaration and a definition and put those in two separate files. One is going to be called operations.h and the other is going to be called operations.cpp. Pause the video, go ahead, set up your project like that and call that function in main CPP and see if you can pull that together. Okay, pause the...
All right, let's get that done. He's given us a task. He's told us to pause the video. We're going to get it done. So we understand how to do this stuff already. This is fairly... This makes a fair amount of sense, I think. So what we'll do, we're going to take this and we're going to put this one in our... We'll just put it in our definitions one. I'm actually going to move this one back over here too. Actually, no. So this is... We moved this from the some other file. Let's move this back to... move this back here. So now, because this is our compare, right? So it makes sense to put our comparison stuff in here, I think. Our some other file we'll use for this one. So this is our inc multiply. So we've done this before. This is our, like when we call this, it increments a and b and then it multiplies them together, and it's good, right? It's whatever. Gotta make sure. Expected a semicolon. Let's see. What is the issue? Because we need this, right? So then we can do one there, one here, and then end it. Right? Oh no. I think we do like so. There we go. Okay. So that one, and then we have this one's compare.h. I think what we can do is we can put our declaration. Let's put our declaration in here as well. This one was just this line, I think. Not even the whole line. It's int increment multiply. We do like this. We end the line. So we've defined it, or we've declared it here, defined it in here, and then here we can go int. I don't even know what we're gonna call it. Let's just say I don't know if it doesn't really matter what we call it. Call it a fucking inc mult result. There. That's very very inc mult. And we'll feed it just let's feed it a 5 and a 10. So the result of this should be 66 based on the way that the math is worked out. And then we'll print it out. We'll take this and we'll call it, we'll call our inc mult result. So the way we've paused it, we paused the video and done as he asked. He wanted us to essentially create this, define it in one place, declare it in another, and then call it here. And it should, the way we've done it, it should be fine. This should be valid C++ code. It compiled, so do we get our result, our inc mult result? Oh, wait. I'll just call this, I'll just say result here. Clear this. Now, does it work as intended? It does. We got our result. It's 66. That makes sense because we fed it the numbers 5 and 10. The numbers 5 and 10 are subsequently incremented to 6 and 11, and 6 times 11 is 66. It couldn't possibly get any easier than that. Let's fucking go. Hell yeah. All right.
The video, do that, and once you are done, come back again and see how I do this. So we're going to set up a new file called operations here.
Oh, I mean, I guess we could have done another new file.
It's going to be a header file .h, and we're going to add another file called operations.cpp. That's going to be our CPP file, which is going to contain our definitions.
Creating even more new files seems a bit extra to me, but it makes sense to do.
So we're going to go in the header here. We should go in the operations header. That's where we want this, and we're going to put in our definition, and we're going to put in our declaration. The declaration doesn't have a body, so we're just going to put a semicolon at the end here. You already know this. We're going to go in the CPP file and put in our definition. This is going to work. And to be able to use this function, we will need to include the corresponding header here. Why is this file called? It's called CCP. It's CPP. We're going to rename it, and we're going to change this to CPP. Okay. Now we should be fine. We should have our things colored
operations.ccp.
And to use this function, we will need to include the corresponding header, which is operations.h.
Kick ass.
Let's do that. We're going to go in main and go down and include operations.
Yeah, he's going to do the same thing that we did for this. To put
and notice
all
that
of that
the way we include
above.
Our own headers is different from the way we include the
standard libraries
or headers that come with the C++ standard library. This is a convention that is used by many compilers. This is how we will have to do things. Please remember this. If you are including your own header, please put that in the quotes like we do
put
here.
Them in
if
quotations.
you are including a standard library header, please use angle brackets like this. Now that we have this included, we can go down here and say result. We're going to set up two variables, x and y. Why not? We're going to have a 4 here, and we're going to have a y, which is a 5. Let's do that. And we're going to have an integer to store our result. It's going to say incr.
Man, he did a lot of stuff that I didn't do.
And it's going to do the operations on x and y. Let's do that. And we're going to print the result here. So we're going to say result.
Well, he did something that I did.
And it's going to be whatever we have in that variable. Okay, if we build this program, it is going to work. We're going to use GCC to build. The build is good. If we run it, we should see our output here. We're going to run rooster, and the result is 24 because, okay, if we increment x, we're going to get a 5. And if we increment a 5, we're going to get a 6. If we multiply these guys, we should get a 30, and that's not what we have here. So what is
Did you
happening?
forget
Let's
to increment one
our
of them?
definition here.
Ah,
Now
it's
we say
incrementing
A
after.
plus
Yep.
plus.
Yep.
We should say plus plus A because we want to increment immediately.
Yeah.
Okay, let's build again. We are going to build successfully.
Debugging.
And we are going to clear and run rooster. Now we have the result that we expect. Let's go back in main and look at our program. This is what we
Now
are
it should be
using
fine.
here.
Result
And
30.
this is
Yep.
the output we expect. This is really all we set out to do in this lecture, showing you how you can set up your project to split functions across multiple files. This is really good if you want to organize your project. For example, somebody who comes to the header here is not going to be bothered by looking at all the definitions and the details of how we compute this maximum and minimum. And we have the flexibility now to move our headers in some other file because we really want to keep the main function or the main file here really clean. We don't want all those definitions to show up here because it is
Organization is important. It sure fucking seems like it.
Hundreds or even thousands of definitions. If you make all
'Cause
those declarations show up in the main
Yeah.
CPP file here, that's going to be really hard to follow and work with. Now we have the flexibility to split those guys across multiple files, and we can even use lots of headers if that is what is going to work for our project. This is really all we set out to do in this lecture. I hope you found it interesting.
I did. I thought it was very
In
interesting.
the next one, we're going to see how we can pass parameters to functions by value. Go ahead and finish up here and meet me there.
Okay, so we're doing, it looks like the next 15 minutes of the video is just pass by value, pass by pointer, and pass by reference. I'm sure we'll figure out all of that stuff. But like, the organization thing is actually super, super interesting. Because so he mentioned before, and this is a thing that I criticized when we did the one definition rule on Wednesday, I want to say it was. When we did the one definition rule, we started using a bunch of things that I did not understand, and the whole point was just to demonstrate that, like, if I define something here, or I guess if I define one of these, right, then I can't use this name for anything else across any of the files that are going to be a part of this program. And like that was, I mean, the point was eventually proven, and I understood what the purpose was, but I was very confused because there was a bunch of other stuff going on. With this, I feel like we could have done the same thing. We could have covered the one definition rule here because he talked about it a little bit, and we could have just been like, oh hey, try to call something max in this file, and it just won't work. Wow, why is that? Because of the one definition rule. Good teacher. He's fantastic. I think it's great. I have very, very few criticisms of this course overall so far. I mean, who knows? Maybe once I get down to like polymorphism or like inheritance or something, I'll be like, oh man, that didn't make any fucking sense at all. But for now, it's been fucking fantastic. It makes the explanations, generally speaking, I think are very. It's given well and it makes sense. There are some times where I'm like, oh man, I wish I understood why we do things in a certain way. But I mean, this is probably the biggest thing for me. Essentially having like a lexicon of like, here's the things that I created for the purpose of using in this specific program. That's huge to me. I love that. You can be like, all right, here's the declarations for all of my all of my different things. Here's what they are and all their and what they're called. And then like I imagine in here I could easily do like increments, values, and multiplies the results, right? And I could like write in what it's supposed to do for each of them. And then I come here and you can see how I intended for that to happen, or the way that I solved that problem. I think that's so cool. Inheritance is easy as fuck. You can use the max in other files after learning classes and inheritance. Nice. That'll be, oh man, this will be so helpful. Dude, I just, it's fucking sick. All right, we're gonna save, this real quick, and then I'm going to close this folder, and we're gonna open, that's me, not you. Yeah, save all. And we're gonna open our, I think this is the last one that we're gonna do, most likely. All right, so this is our last thing. This is probably going to be the last one. I'm going to try to get all the pass-by sections done in one file, because then I don't have to create a new one. All right, let's continue.
In this lecture, we're going to see what is meant by passing parameters to a function by value. And we're going to look at an example of that. Here we have a simple function called, say, age. It's going to take one parameter, which is an integer called age. And in the body of the function, we are printing out the age after incrementing it. Suppose this is something useful for your program. The function is split into declaration and definition. We have a declaration on top here, and we have our definition below the main function. In the main function, we will attempt to use this function. We're going to call it down here, and we're going to pass a local variable, which is called age, as our age. When we do that, we expect this to print you are 24 years old, because we're going to increment the age, and we're going to say, hello, you are 24 years old. This is what this program is going to do. But we want to keep track of how the outside variable here is going to change, and the age we have passed as a parameter here. Because this age we pass as a parameter is not going to be the same as the age we have on top here. What we pass here as a parameter is going to be a copy of the actual variable that we passed here. And this mechanism is called passing a parameter by value. And what you really pass is going to be a copy, and what you work on inside the body of the function is not going to be the original stuff you passed as an argument to the function.
Doesn't this... so it seems to me like the way that this is... Oh, never mind.
So we're going to try and prove that here. We're going to print the age before we call the function. We're going to print the age after we call the function. And what we print here is going to be the outside variable, because here we are in the scope of the main function. Inside the sayAge function, what we're going to be modifying is a local copy. So we expect the age here to stay the same before and after the function call. So the way this is going to work, when control hits this function here, it's like we're going to have a situation like we have here on the left. We're going to set up local copies in the function that are going to contain whatever was passed as an argument to this function. And this age here was passed as an argument to our function. So we're going to have a local copy of this age, and we're going to store it. And it is what we're going to be manipulating in our program. When the function goes out of scope, the local copy is going to die, and the outside
this is the same in loops for and while.
To be unaffected. Let's head over to Visual Studio Code and show you this in action.
All right, let's practice this. This is going to be interesting.
Our working folder, the current project is pass by value. We're going to grab our template files.
I imagine once we get pass by value understood, we can apply similar principles to
open this up in Visual Studio Code. Let's do that. We're going to open the folder
other
that
pass bys.
The project pass by value. Let's do that. We are going to open it up, and we're going to go in the file and clean it up a little bit. And we are going to set up our function. It's going to not return anything, and it's going to say age. and it's going to take an integer, which is going to be our age. And inside, we're going to increment our age. I think this is what we saw in the slides. And we're going to say however many years you are old. We're going to say, hello, you are age old. And we can set up a variable in the main function. We're going to call it age. And it is going to contain 23 as our age. We're going to say age, and we're going to pass in our age here. We can do that. If we're trying to run this program, let's try to do that. We're going to build with GCC, and we are going to bring in a terminal we can use to run this program easily from Visual Studio Code here. Let's run Rooster. We're going to say, hello, you are 24 years old. And this is what we expect, because when this function is called, we're going to increment the age, then we're going to say the age. But we want to see what happens to the outside age here if we modify the inside age that we have on this function here that was passed as an argument. And again, what you pass when you are declaring your function is a parameter, and what you pass when you are calling the function is called an argument in C++. Please remember this. Okay, what we pass as an argument is our int age variable, which is local to the main function. And we're going to see what happens to it. Let's print the age and say age before call. I think this is descriptive enough, and we're going to print that. And we're going to go after the function is called, we're going to say the same thing, but we're going to say after call. And by after, we mean after we call the function, say age here. I think this is descriptive enough. And we're going to see that if incrementing the local variable to the function here affects the variable that we have in the scope of the main function. Okay, so let's see that. We're going to build with GCC as always. And the build is good, so let's clear and run Rooster. You're going to see that before the call we have 23, and after the call we have 23. We didn't change the second call.
Oh.
This is a classical copy-paste error.
Yeah, I mean that makes sense. That makes sense though. I mean this. Oh, okay, right. Because we covered this a little bit before. So what we did here. Oh man, this is a little bit weird, but it's because it's almost like redefinition, but not quite. Because like what we did here is we had our local thing here, right? And when we passed a value into it, our argument was 23, and then 23 is within the void, or within this void function called say age. 23 is the value of age, and then age gets incremented by 1, and then comes through here. But then as it exits this function, as it leaves, it's no longer it's no longer beholden to this. This is no longer this incrementation doesn't hold out here because it's outside of the brackets. That is
error. We're going to change that.
Makes perfect sense.
For our program to really be
I love that.
descriptive enough. Okay,
I think this is because the upper age is a different variable than the main function age, and different variables, like different storage points. I mean, that kind of makes that is kind of how it makes sense. Like I don't know exactly how it handles like the redefinition thing. I don't think, because it's not like this is we aren't defining age as. I don't really understand how that works. I think that it's because it's not a. Yeah, I don't know. I don't know. I don't quite understand. I know that that this works. Like I mean, we could call this. We could call this anything. We could call it freaking twee, right? And then we'd pass in. All we'd do here is we'd increment twee, and then we'd have to do our new thing, but it would be exactly the same thing. Like it just kind of it prints the same information, right? The only thing that I'm not 100% on is why we can use age twice there, and it's like different. If it's different storage points, then I mean, that. I mean, I feel like it has to be different storage points, obviously, but because like if we do pointers at this and then at this, it would be different. They would. I'm almost well. They would have to be different things, right? Or maybe it wouldn't. Maybe it's because it's the same. Two different functions, I guess that's why. Maybe it's because it's the same thing. Well, but then I changed it to twee and it didn't matter. I don't know. I don't know. I don't understand it. I just know that it works. That's maybe he'll explain it. There have been times where I've asked like, "Hey, I don't understand. How does this work?" And then he explains it immediately after. It works because both age variables are in two different scopes. But it's not like the scopes make sense, but what I'm curious about is why I can still call it age because this I mean this isn't redefinition technically, right? But like when we have things across different files, right? Like is it literally just because it's inside the same brackets? But no, because I can't define something out here as like I can't do like int age and then have this be 15, can I? Does that work? It does. Oh my god. It's literally just because they're in different scopes. Right? Because if I try to do a different age here, it doesn't matter. Or it won't like it. And then if I do it if I call a different thing here out here, like if I call a different function, uh if I just say int fucking if I call it say age, it won't matter. It won't like it because I do different thing. If I do something different in here, right? Because it'll be like, hey, that's the same thing, right? Surely. +1 overload. What does that mean? That example you just did works because of variable shadowing. The local variable age overshadows the global. If you want access to global, use colon age. So if I did this, or I guess the global scope has no age. I mean, I guess that makes sense because we've only done this. But if I no, if I do like this, I could do and then this. But if I get rid of this, then this suddenly says the global scope has no age. Oh, you need to re-add age to do it. That is the reason why most people don't use namespaces. What do you mean by namespaces? Is that like, well, actually, I just don't know what a namespace is. Is it just is that just what like this thing is? I don't know. All right.
World is good, we can clear and run rooster. And now we have before call 23, after call age is 23. It wasn't changed by what we have inside here. And we can even go further and look at the memory addresses of these guys. Here we can try and print the address of the age variable. Let's do that. We're going to say address of age and put that out here. We're going to say address of age. No big deal here. We can close the pane on the left here because it is taking up valuable space. And we're going to go to the second statement and put in the address of age. And we're going to print that out. We can do that. Now we know the address of operator. Okay, we can do that. And when we hit the body of our function here, we can also print the address of age. No big deal. So we can say address of age. Let's do that here. And we're going to print the address of the local age variable here, which was passed as a parameter here.
Using namespace std. Now you don't have to write std cout, blah, blah, blah. Here, std can be removed if you use namespaces. Oh, okay. Okay. I guess that makes sense. Age. Hello, you are however many years old. And we do age. So we're just typing out the address. Is it? Oh, I'm curious why we're doing this.
Okay, now we can build our program.
Oh, let's try it. Terminal run task. What is going to be this? Let's clear this. So these have different. Well, I didn't do the one for after call. I don't know if he did that. So these have different places in memory. So our age before call and our age after call have different things.
Program and watch those addresses. We're going to build with GCC. The build is good. We can clear and run a rooster. Now you see that the outside variable is going to live at an address that ends in DEC, and the local variable is going to live at an address that ends in DC0. So this is a completely new memory location that we are using, and it is just going to contain a copy of what we passed as a parameter here. And the compiler is going to take care of setting up this copy variable and have it available for...
Oh god, is this their explanation of scoping? No. This is actually about pass by, which I guess might have something to do with scoping, but we're doing pass by value is the purpose of it, at least.
For use in the local
it's resulted in
a
discussion about scoping.
But we have to be aware that what we are working on in the say age function here is a copy. It's not the original value. This is really all we set out to do in this lecture, making you aware of the call by value mechanism. And the main message is that what you are working on in the body of your function when it is called is going to be a copy of what you have passed as an argument when your function was called here.
Okay.
In this lecture, we're going to
pass
see how
by
we can
pointer.
pass
oh boy.
parameters to functions by pointer. This is going to allow us to avoid the copies that we were experiencing when we were passing parameters by value, like we have seen in the last few lectures. Here is a simple example showing the syntax we can use to pass parameters by pointer. On top here,
this makes me happy. I mainly use Python.
Declaration, and down
Why?
here we have our function definition, and you see that the syntax is the same. We are passing by pointer and by pointer in the definition here. And another thing you should be careful about is that when you call a function that passes by pointer, you have to give it an address. And that's what we are doing here. So we are passing
way too much effort.
Of our
is Python that
variable,
much easier?
Which is going to be passed by pointer. When we pass by pointer, we want to be modifying a copy inside the body of our function. If you look here, we are incrementing the age variable, but we are doing this through the referencing. So when we pass a pointer here, the pointer is going to contain the address of this guy, and in the body of the function, the pointer we will have, this age pointer, is going to be pointing to the original variable here. Okay, so this age pointer is going to be pointing to the
Python
original
is the
age
coding
variable.
equivalent of Todd Howard.
When we dereference it and modify
it just
variable,
works.
we're going to be
I guess yes, but it's very slow. That's
really
also very Todd Howard.
And this is really what passing by pointer is all about. You declare your functions by passing in pointers like this, and in the definition you do the same. And when you call the function, you need to pass in an address of the variable, because that's what we store in a pointer here, and this is going to work. If we try to run this example, here we're going to print 23 because that's the original value. We are going to call this a age. We are going to increment,
Who needs
and
big
this is
O if
going
it's
to
only
change the
100 lines
original
long?
value. If we print here, we're going to get 24. And when this function terminates, we're going to hit this statement here, and we're going to print 24. This is what we're going to see when we get to run this program here. And this is really all there is about passing by pointer. We are going to head over to Visual Studio Code and play with us a little more.
Oh
Okay,
boy.
here we are in our working folder. The current project is pass by pointer. We are going to grab our template files here.
I can't wait to
And
see
we're going
how
to
we
put
do this
them in
because
the current
I'm
project,
not gonna
which
lie.
is pass by pointer. We are going to open this in Visual Studio Code pretty
was
quick.
like-
We're going to choose that, pass by pointer. We open this,
Pointers
and
are-
our main CPP file
they're
should show up
fine.
here.
It's not
We're
too
going to
bad. I
clean
kind of
it
understand
up
what
a
they
little
are.
bit. We are actually going to grab the code from the last lecture and put that in here, and that's going to be our starting point. Let's close the left pane here so that we have some breathing space. The function here, say age, is going to pass by pointer, so we should take out this const here and have a pointer here like we had in the slides. We're going to do the same in our definition here. If we go down, we're going to do that. We're going to pass by pointer, and we are going to uncomment the line that increments our age here. Okay, after we do that, you see that we have a squiggly line at the
All right, let's see. I'm learning C++ because I want to replace JavaScript with C++ and web dev for with some frameworks. Best C++, just that much faster. Is it? I mean, I've heard C++ is like, and what is the term for languages like C? Is like they're overall more efficient because they're fucking, I don't know, something about them being closer to the kernel, I think. I don't know the details of it. Low level. Yes, low level. That is my understanding. Is that they're just like C languages tend to be, I think are lower level, which is part of, it's one of the things that I think is attractive about learning it as well, because I like understanding why. I like understanding the why a lot of the times. All right. So we have our sage, we've created our declaration here. Declaration. I'm going to call this pass by pointer. We're going to see about pass by pointer. Bump it, bum bum bum. All right. Creating our void say age. Learn assembly? Oh no. Why would you say something like that? Alright, so I do this, and then we do plus age. Then we have our cout. Hello, you are. And then we have our thing. Age. Years old. And then we do the address of age. You know, looking at this, I probably could have just uncommented the shit that I did from the last one, but I also kind of want to hold on to that in case I need to look at it later so that I can understand it. I still have all of my old, all of the old lessons. So, parameter. Alright, pass by pointer. So we have int age 23. Local. And then we have std cout. See, I'm looking at this and it's like pretty much exactly the same. What if I just copy this? What if I just copy? No, I don't want to cut, just copy. What if I just copy it and put it here? What if I do that? Is there anything stopping me from doing that? I guess this part. So we can do cha-chung. Perfect. Maybe. Alright, yeah, looks good. Looks good.
this
Looks
line
good.
that calls the say age function, what we need to do is to pass it the address of the age variable here, like we saw in the slides. So this is the syntax we have to follow. Once we do this, this program is going to be valid. And
oh, wait, hold on. So I do this. So void say age, an integer pointer called age. And then here is the address for age, which I assume is referring to this one. And then we increment the value in age. Is this whole thing already dereferenced? Is that what it is? No. No. There's no way. That's not what it is. If we have our integer pointing at age, our integer pointer for age. So this is our definition, and it's called here. Yeah, that's our declaration. So then we've defined it here. So when we call this, we have it pointing at age. So is this one going to actually change the original? Because this, by the looks of it, is going to point at this and change the, and it seems like it'll change the value in, at least in this scope. And it's not just changing it in the local, like inside the function. That's kind of what it seems like is going on here. It's that the difference between pass by pointer and pass by value will be.
And if we run it, here we're going to print 23 because that's the value we have in here. We're going to call the say age function. We are going to increment age, and here we forgot to do our dereferencing. So
okay, so we do need to dereference that.
is to dereference the age and increment it. This is going to increment the original variable here, and we're going to be accessing this through the dereferencing operator of our pointer here. If we hit this line in the function here, we're going to print 24 because the value has been incremented through this statement here. And after the function call, we're going to hit this statement here on line 10, and it is going to print 24. This is what we expect. Take a moment to make sure you really understand this. The things you need to be careful about is the syntax we use to declare the function. Here we say that we are passing by pointer because of this little star here. And we have the same thing when we hit the definition of the function. We have this little star. So we are passing by pointer. Another thing you should remember is to pass the address of a variable when you call the function like we do here. And please remember to use the dereference operator whenever you want to modify whatever variable is living at the address that you passed in here. So that's why we are dereferencing here through the star operator like we are doing here. This is really all you need to be careful about. So
yeah, that's it. You know, just 4 things.
This program. Let's do that. We're going to build with GCC. The build is going to go through. We need to bring in a terminal so that we can run this program. And again, we expect to see a 23, 24, and 24 here printed out. So let's run Rooster. Okay, here is our output before we call the say age function. The age is 23, the address is DEC. When we hit the function, we are saying, hello, you are years old. So here we should have dereferenced to.
So here. Yeah, this needs to be here, right? So that we can get the actual value. Because as it is, it's just printing this thing. Okay. There we go. That makes a little bit more sense, I think. Terminal run task. Let's see what it looks like when we do it correctly. So this one says 23. Our age before call is 23. And then we have our our address is this fucking value, and then we have in the function we have we've incremented it by 1. We have our next address, which is different. I'm going to I'm going to look at his as well, but it's also changed it's changed the address, or it's changed the value at the same address of the last one.
To access something inside the variable here. So we should say you are age old. We need to dereference this guy because now it is a pointer. I forgot that. I really am sorry, but we are learning, so this is a good learning chance for you not to make the same mistake as I am making here. So let's try and build again. We should see the correct output. We are going to clear and run rooster. Now we see that before the call, age is 23. When we call the function, age becomes 24 because we just incremented through our dereference operator. And after the function call, the age is going to be 24 because we have modified the original variable here through our dereferencing of the pointer here.
Ooh.
This is really all there is about passing by pointer. This is the syntax. You have to pass a pointer in the declaration. You have to pass a pointer in the function definition. And when you call the function, you have to use the address of the variable and pass that as an argument to the function. And whenever you need to use the passed parameter, you're going to go through the dereference operator like we did here and here in the body of our function here.
Yeah, that makes sense.
In this lecture, we're going to see how we can pass parameters to a function by reference.
All right,
and
reference.
This is another technique we can use to avoid passing by value.
Now, I remember references being something that I was kind of like iffy on why we needed them at all. I mean, like, obviously, everything has its use somewhere. Just because I don't know what it is doesn't mean that it is truly useless. But I remember being like curious as to what the hell the reason that we were learning the reason that we were learning these things for reason that we were Jesus, I've like said the same thing like 3 times now. But I remember being confused as to why one would use a reference if in general. It seemed very it seemed like extra work that didn't really provide any kind of benefit. Like I could see at least not for the integers that we were doing. Like with I could see, I think I mentioned that I could see a value for it in like when using const when you have like a const one that you want to not change, and then you have like the reference that you do want to change. I mainly use them in function parameters. Modular code across files. I'm sure, like I said, I don't know. I don't know. I don't know how all this works. How it'll all work together. Basically, for what you said, though, mainly constants. I mean that's I think that's like the first. At least it's the most obvious one that comes to my mind when I think about it. It's like, I don't know. Why else would I want to do that? But yeah, still. Let's see what this pass by reference looks like.
Which is going to create a copy. And the syntax is really simple. If you look at the declaration here, you're going to see that we say int reference. And again, if we hit the definition, we're going to say int reference, as you see here. When we call the function, we don't have to pass the address of operator. We just pass the variable because this is going to be treated as a reference by the compiler. And in the body of the function, we don't have to go through ugly dereferencing like we did with pointers. And hopefully you can see that if you want to avoid copies, passing by references is much cleaner. You don't have to use the address of operator when you call the function.
I'm gonna go to sleep.
Like we do here. And
yeah, go for it, man. Get some rest.
Through dereferencing.
Have a good one.
To access and modify your variables. And the modification we do here by incrementing age is going to be seen on the outside because we are going through a reference. And the reference is a true alias to the variable that the reference is referencing. So by incrementing the age here in the body of the function, the change is going to be seen after the function call. Before the function here, we're going to get 23. In the body of the function, we're going to get 24 because we just incremented the function.
Yep.
And after the function call, we're going to get a 24 because the change was propagated to the original variable. And the reason is because we are going through a reference here. Let's head to Visual Studio Code and actually play with this a little more. Okay, here we are in Visual.
Honest to God, when you finish this video, I'd love for you to do one on like Java or Python and see the difference. I mean, maybe. The initial plan was to go into like Unreal 5 and start doing game dev stuff. It might be worth it to go into like Java and the others though. I feel like hopefully with something like with this one under my belt, something like Python would be much easier. And I'd be like, "Oh yeah, I recognize this. I know how this works."
Visual Studio Code, the current project is passed by reference 1710 here. So we're going to grab our template files and put them in place 1710. Let's do that. And we are going to open this in Visual Studio Code pretty quick. Let's do that. The main CPP file is going to show up here. Again, we are going to grab the code from the last lecture and use that as a starting point. And we're going to be modifying the signature of our function here. So what we want to do is to pass by reference. We're going to say int reference here. You already
Memory
know
safe languages go
from
hard.
the previous chapter. And we are
I'll
going
wait till
to
you get
hit
into
the
derivatives
definition here and do the same
boy.
thing. So let's say int reference age. And
All right, so this one's gonna be int reference still age. This is gonna be just like this. I think we want change this. The fuck p thread after it gets stacked at her. What the hell is this? I must have stopped something. Alright, so we have our int main. Let's go into here. We can go. Let's copy. I think it's just the same text for the most part. Not quite identical, but pretty much. So we do this. Local units. All units. Because people like those languages, but not their syntax, so they change it. Best example is Kotlin, Java that reads like Python. What the fuck? That sounds bizarre to me. It's like, ah, yes, it looks like one thing, but you have to treat it like it's another. I feel like once you know one, that would get confusing, wouldn't it? It's great. I'm gonna have to take your word for that for now. We can see we can see when I maybe understand things a little bit better. Argument 80% because Java is like 80% boilerplate and Kotlin cuts out like 60% of it. That sounds like it's cutting out a lot of the language. But if it works, if it works, it works, right? That's kind of the key. Okay, let's continue.
And when we call the function, we don't need to pass the address of operator because this is a reference. We can use it right away. The compiler is going to know that this is going to be a reference to the original variable that we pass here. And in the body of the function,
wait, hold on. Did I fuck something up then? I think I fucked something up. We have our void. Okay, yeah, I didn't include this. So void say age, and then this is int reference age. So this is our pass by reference. I think this is this is our declaration. I don't need to put in declaration. And then this is our actual thing, which I think it's got the same. He still has the pointer in there, but we'll see. We'll see if that changes
here and do the same thing. So let's say int reference
Yep.
age.
Yep.
And when we call the function, we don't need to pass the address of operator because this is a reference. We can use it right away. The compiler is going to know that this is going to be a reference to the original variable that we pass here. And in the body of the function, let's take out this last line here. We don't need it. And in the body, when we want to modify the reference, we can do that right away without the referencing. So we can just say plus plus h here.
All right,
and
cool.
the changes are going to be propagated to
sense.
the original variable here because we are going through a reference. Let's go down and modify this because this is a reference. We can use it right away. And we can close this left pane here so that we have some more breathing space. And you see that Visual Studio Code is no longer giving us any squiggly lines. So this must be valid C++ code.
That is
Again,
logically what you would
notice
expect.
The syntaxes we are using here.
Okay.
We are passing a reference in our declaration. We are passing a reference in our function definition here. When we call the function, we don't need to do any address of operator. We pass the variable as is. And in the body of the function, we don't have to do any dereferencing. We can increment right away or modify the variable however we want. The changes are going to be propagated to the original variable because we are passing a reference. So the incrementation here is also going to affect the original variable that was declared in the main function here.
Yeah, it should do the same thing here, from what I understand. It should do the same thing as this was when we did the pass by pointer. So these are the same address, and the value has been changed. And then this one is new because it's the local one for the function.
To use our variable, we're going to just use it right away. We don't need any dereferencing. And if we print the address of age here, we're going to see the same address we see on the outside because this is a true alias. It's going to be referencing the same variable that we have in main here. Okay, now that you have a better idea about this, we are going to try and build this. We're going to use GCC as always. You can see that the build is good. If we bring up the terminal to try and run this program,
I understand.
We can clear and
dude, I'm fucking understanding shit. It's amazing.
Before we call the function, the age is 23, but the address ends in DEC. When we hit the function, the age is 24 because we just incremented that here. But notice that the address of the variable is the same as on the outside. So we are modifying the same variable.
We're modifying
and
it.
when the function is done,
beautiful
the age
that it
is
works
still
exactly
going
how
to be 24 because we
should,
just modified
frankly.
the original variable through a reference here. Okay, this is the effect of passing by reference. You can use a clean syntax to modify the original variable in your functions. And this is going to avoid copies like we have seen when we were passing parameters by value a few lectures back. I would like to welcome you.
Hey, wait a second. You can't just immediately start the next one. This is chapter 12 that you're doing, buddy. You didn't say go ahead and finish up here and meet me there. But anyways, guys, that's the end of this chapter by the looks of it. So that puts us we're over the hump now. This video is 31 hours long. We're at the 16-hour mark. That's over halfway. We're over halfway done. I'm gonna go ahead and we're gonna close this, and we're gonna get all of our stuff over. What is this? This is our thing. So chapter 12. That's the wrong thing. There we go. And this one's called getting things out of functions. This is at the 16:03:21 mark. Look at this, dude. Holy shit. All right. I'm going to go ahead and come over here. I hope you guys... what the hell? Okay. I hope you guys have enjoyed hanging out with me today. It's been a lot of... this has been... I complained a lot about the last time because it was very... I think the beginning of this chapter was... it could have been handled a little bit better. But this has been a fantastic one so far. Very useful information. Lots of very... Lots of very important things that I'm glad we've learned, and I'm hoping that we'll get to apply again in the later chapters. We'll see. It should be. We're like we're over the halfway mark with this video now. So I mean that's not insignificant. That's a pretty good chunk of I mean learning that we've done. I don't know that many people who have actually gone through and watched this whole thing. The video has like a little under 6 million views, which is, I mean, that's a fucking lot. But I don't know how many of those are like people who sat through and watched all 31 hours of it. So hopefully we're gonna be part of the few there. I, hopefully for me, I don't wanna. I want to be special and cool. But anyways, guys, it's been a lot of fun hanging out with you. I hope you guys enjoyed hanging out with me. We'll be back on Monday with some more C++. Over the weekend, I'm going to be pretty busy for the most part. I think I'm doing one stream at 11 p.m. on Sunday, but I don't have any. Uh, even that one is subject to change. Not super likely that it'll be changed, but you know. I hope you guys had a good time. We'll be back then. See you later. Bye. I'm gonna leave now. Goodbye.